My name is Christian. I'm from CSA Catapult, which is Compound Semiconductor Applications Catapult. The Catapults bridge the gap between university research and the industry. And as part of this, we have a consortium between CSA Catapult, BMW, Warwick University, Lyra Electronics, and Custom Interconnect Limited. The goal of the project, which is called At Future Bev, is to investigate 800 volt silicon carbide technologies for next generation vehicle inverters. The technology is really interesting because the developments in semiconductors, compound semiconductors, has led to real available efficiency improvements, performance improvements, and then weight reduction through changes in passives and switching frequencies. It can be done kind of safely, robustly, and have good reliability lifespan. So the project is APC funded, and it's 4 years, and we're now in the last quarter of the 4th year, where we're looking to develop follow-on activities with all the key partners to really make the most of the technology we developed across the last 4 years. It's been a huge success. We've been able to create a portfolio and offer real embedded expertise for each of the partners and bring them to the core of the UK semiconductor industry. So one of the key things is when you have a die, so a little piece of glass that does your semiconducting, so on and off conductivity. Then once you have the die, you then have to do a lot of packaging around it. And previously that packaging was able to be fairly inert and simple. But actually, with the higher switching speeds and the higher turn-on speeds, which enables a lot of the efficiency gains that we're interested in and weight reduction of the overall powertrain, suddenly the shape of all of the little traditional electronic legs becomes really important. And we've been working to optimize that, and that then the interface into the controlling inverter around that throughout the project. Really proud of what we've achieved and the number of UK businesses that we've interacted with and European businesses, and the education we've been able to provide and generate for all of the partners, working with the requirements that BMW have set out for us, and then all of the process partners kind of have generated and learned around the various standards. Silicon carbide technology sits really nicely between silicon and gallium nitride, where the losses available in the die, so this is what you pay for trying to convert your battery energy into your motor energy, that is essentially the efficiency loss of these little semiconductors that all of the power through the car goes through. And that's very roughly the size of Cook's matchboxes, which is amazing when you consider that at peak power they'll be switching the equivalent of an entire street's worth of houses on and off, and they'll be doing that thousands of times a second. So that's quite a lot to work with. So these losses in the die, they almost all go to heat, and then we have to get rid of the heat. So actually, if we're able to reduce the losses, we also reduce the heat losses into the vehicle, and then we can reduce the cooling, and it becomes this wonderful virtuous cycle that people talk about. So efficiency essentially means a continuous improvement towards more efficiency, more weight loss, and impact for the environment, which is phenomenal. And what's really interesting is when you start thinking about this technology scaled over a lot of vehicles. If you think about, say, a typical run of vehicles being maybe 100,000, you give them 100,000 miles lifespan, very roughly, you can quickly see that a 1% improvement in efficiency is equivalent to many millions of road miles just sort of swept off and not impacting the environment. So we can also offer then increase in range and performance and all of the positive things you'd like to see in a vehicle. So it really is an exciting piece of technology to be working on and improving. There's a rapid change in the dies that are available in industry as well, so we expect that trend to continue and these improvements to continue to scale, which is really exciting.